right, guys, so we have moved on now to 13C. Remember, we are still solving one-step equations. It's just that today we are looking at fractions. So remember, step 1 is draw the line of equality. Step 2 is circle the variable. Please don't skip these steps. Circle the variable so you can see where it is and what's being done to it. And then finally, step 3 would be do the inverse operations or do inverse operations. We're going to do the opposite to get that variable back by itself. So number 1, draw the line. Number 2, circle a variable. Number 3, do inverse operations. Now remember today, though, we are going to be working with some fractions. And so remember with fractions, if we add or subtract, we need common denominators. Multiplying means we can either cross-cancel first or just start off going straight across. And dividing means keep, change, flip. All right, so we already had this little discussion of what to do in each of these situations. Remember, here we should add. The answer would be, oh, I put negative. The answer would be positive. Here we would have multiplied. The answer would be negative. Here we would divide. The answer would be positive. And here we would add, and the answer would be negative. So we've already had that discussion, but now we're going to actually do the work. So let's go ahead and look here. Here's our very first real example that we're going to work out. So let's follow our steps. We're going to draw that line of equality so we can see what's separate. Here's this side, here's that side. We're going to circle where the variable is. There it is, right there. And we need to work backwards to get this one isolated. So right now they're adding a negative 2/3. To make that negative 2/3 go away, we will add 2/3. Because negative 2/3 plus 2/3 are additive inverses, so we know those will cancel out to 0. I'm going to bring down what I had left here. That's a C, and that's an equals. Now, whatever we do to one side, we have to do to the other. I'm going to go ahead and write it this way, plus 2/3. But obviously, I can't add it the way it looks there, and so I'm going to write that on the side. All of these fractions, for the most part, have to be written out on the side. We can't really get away from that. So we're adding negative 29/5 plus 2/3. Now this is an addition problem, so we need common denominators. Between 5 and 3, a common multiple would be 15. And so let's make both of these 15ths. To get to 15 from 5, we have to multiply the bottom and top by 3. All right, so there's some more side work I have to do. 29 times 3, that's going to be 27. 3 times 2 is 6. Plus 2 more is 8, and so I get 87 there. So this is negative 87. To get to 15 from 3, we multiply by 5, bottom and top, and that one I can do in my head. 2 times 5 is going to be 10. Now, do I have more positive or more negative? Well, I have more negative. How many more negatives do I have? Well, this means we're going to subtract, and so I would have 77 more negatives over 15. And we can't reduce that, and so we're going to leave it that way because most of the programs appreciate it in improper form rather than mixed number. So I'm going to say our answer is negative 77/15. There it is. All right, so how do we check that that's right? Remember, we take this original equation and we plug it in. We're going to replace that C with what we think it equals. So that means in our check, we're going to write the original problem. Negative 29/5 should be equal to negative 2/3 plus our answer, negative 77/15. All right, so I've got to make common denominators here, again, because it's adding. I'll bring down the negative 29/5 that I'm supposed to get at the end. And let's make the common denominator 15. All right, when I make it 15, that means I'm going to be multiplying this by 5, bottom and top. And I get negative 10 up here, plus negative 77/15. All right, so negative 29/5 should be equal to, what do I get here? Well, be the same, stay the same. Our denominator is going to be 15, and negative 10 plus negative 77, these are both negative, everything's negative, so that's going to be negative 87/15. Well, wait a minute, I thought I was supposed to get negative 29/5. Remember, we do have to reduce. And so in this case, I'm going to try reducing by 3 because I know that would change the 15 to a 5. So I'll rewrite my answer, negative 29/5 should equal. That would make the bottom here 5. Let's check 87 divided by 3. 3 goes into 8 2 times. That gives me 6. We have 2 left over. Bring down the 7. How many 3's can I take out of 27? 9. And so that means if I take negative 87 and reduce it by 3, we get negative 29. And since negative 29 fifths equals negative 29 fifths, we know our answer was right. All right, let's move on. Notice there's not as many examples with this one because fractions take a little longer. Adding subtraction takes the longest. Draw the line. Circle the variable. What did they do to the end this time? This time they added 7/2. So to undo that, I will subtract 7/2. And this time I'll go ahead and write it to the side over here, minus 7/2. I know these two will cancel each other out because they're additive inverses. Oops, this is an N, not an M. N would equal, well, I need common denominators again. I'll go ahead and write them over here. So that's going to be negative between 5 and 2. Let's make that common denominator 10. And over here, 10. That line's a little long. And we're going to be subtracting. So to get to 10 from 5, I have to multiply top and bottom by 2. So that makes it negative 8 tenths. To get to 10 from 2, I multiply by 5, top and bottom. That makes it minus 35 tenths. Remember, a subtraction is really add the opposite. And so what I really am looking at is negative 8 plus negative 35, which if you can do that in your head is negative 43. Let's check that. 35 and 8. 8 and 5 is 13, and yeah, we get 43, just to check. All right, so we have negative 43 tenths. That would be our answer, negative 43 tenths. So I'm going to write it like that. We can't reduce it, so I keep it that way. And in my check, I will replace that n now with what I'm saying it's equal to, which is negative 43 tenths. Plus 7/2 should equal negative 4/5. Now I see between 10 and 2, 10 would be a good common denominator, so I'll keep this one the same, negative 43 tenths. But I'll change this one into a denominator of 10. To get there, we need to multiply top and bottom by 5, and I get 35 tenths equals negative 4/5. All right, let's check this now. Be the same, stay the same, those are the same, so I'm going to write that as tenths. I'm going to write it small right there. Sorry, it's getting so small here. Negative 43 plus 35. Do I have more negatives or more positives? Well, I have more negatives. And I would subtract. So 43 minus 35 should give us 8. Equals negative 4/5. Now, wait a minute. I'm supposed to get negative 4/5. What happened here? We just have to reduce. 8 tenths reduces down to negative 4/5. Since that checks out, I know our answer is correct. All right, so adding and subtracting takes the longest. Multiplying and dividing is actually the faster way to work with fractions. So we're going to draw the line, circle the variable. So right now, what's happening to that variable? What does it mean to be attached? Well, if you remember, that's a coefficient. So since that's a coefficient, it means it's being multiplied by that variable. Since they multiplied the variable by 4/5, we are going to divide that variable by 4/5. And whatever I do to one side, I'm going to copy to the other. But this time I'm going to write it to the side. Divide by 4/5. Okay, I know that this looks a little weird, but we also know 4/5 divided by 4/5 is going to equal 1 because it's the same thing top and bottom, even though it's a weird looking fraction thing. I'm going to bring down 1x, and then let's see what that's going to equal. Remember, with dividing fractions, keep, change, flip. So I'll do my side work over here. That means it would be negative 7 over 2 is our keep. Our change is changing to multiplication. And I'm going to flip over 4/5 and make it 5/4. Now, because it's multiplying, I check to see if there's any cross-canceling that could occur. Here there's not, so we're just going to multiply straight across. Negative 7 times 5 is negative 35. 2 times 4 is 8. I can't reduce that at all, so that's just going to be my answer. Negative 35 over 8. Now we check. That means I should be able to take 4/5, take out the x, replace it with what I got, negative 35 over 8, and the answer should be negative 7 over 2. All right, so let's do this multiplying. Here we can cross-reduce. So 4 and 8 both have 4's in them. So how many 4's can I take out of 4? 1. How many 4's can I take out of 8? 2. Now 5 and 35 both have 5s. How many 5s can I take out of 5? 1. How many 5s can I take out of 35? 7. So now it says 1 times negative 7, which is negative 7, over 1 times 2, which is 2. And it does come out equal to negative 7 over 2. So we know we're right. All right, last problem. Here's the weird looking one. See how that looks? Okay, so let's work this out. Okay, draw the line. Circle the variable. What is being done to this variable here? My goodness, look at that. Well, what did they do? They used this fraction bar. Remember that fraction bar means division. So what are they doing to the d right now? They're dividing d by 3/2. So if I'm dividing the variable by 3/2, then what we need to do to undo that is multiply by 3/2. Remember, because it's the same thing up top and bottom, those cancel out to 1s, and all I would have left here is my variable, d. But whatever I do to one side, I've got to copy to the other. So I multiplied by 3 over 2, so I'm going to multiply by 3 over 2 over here. Now, I could just go ahead and do this multiplication, but remember, it's a good idea to check for any cross-canceling. 2 and 5, no, but 3 and 9 both have 3s. So I can take out, how many 3s can I take out of 3? 1. How many 3s can I take out of 9? 3. Now when I do the multiplying, it should already be reduced. So 1 times negative 5 is negative 5. 2 times 3 is 6. And so I get my answer, negative 5/6. All right, all we have to do now is check. So the original problem said negative 5/9 is equal to, well, we're saying d is negative 5/6, and it's being divided by 3/2. So I'm going to write it like this, divided by 3/2. That's the same thing. It's just easier to see. All right, I'm going to copy down the answer I'm supposed to get, negative 5/9 equals, remember, keep, change, flip. So I'm going to keep negative 5/6, change to multiplication, flip to 2/3. Now we want to check for any cross-canceling. 5 and 3, no, but 6 and 2 both have 2s. So how many 2s can I take out of 2? 1. How many 2s can I take out of 6? 3. So now I'll copy everything down. Negative 5/9 should be equal. Let's see. Negative 5 times 1, negative 5. 3 times 3, 9. Yay, it came out equal. That tells me my answer was correct. Remember, this is just checking to make sure we're right, and you can do that on every single problem. Always check your work because you should be getting 100% every time. All right, so that's it today. We just have one example for each operation, adding, subtracting, multiplying, dividing. Remember, if you have any questions, raise your hand. Come see me at the conference table. You guys haven't been doing that a lot lately, so come see me at the conference table, ask me questions, go over a problem with me or two, and make sure that you understand how all of this works. Have a great day. Yay, math.